right, Honors Chemistry, we are now starting Unit 2, Atomic Structure and Nuclear Chemistry, Section 1, Atoms. This is kind of a long section, so I'm going to move through kind of quickly, so you may want to pause periodically to take notes and then listen to what I have to say. All right, so to start off, we're starting with the vocabulary term elements. Elements are any substance that really cannot be broken down any further from where it is. This is what the entire universe is built out of. Elements are organized on the periodic table, and every single atom of an element has the same number of protons. So we're going to define what a proton is in a few minutes, but every single carbon in the entire universe has 6 protons. If it gains a proton, it's not carbon anymore, it's nitrogen. If it loses one, it's not carbon anymore, it's boron. So they have to have a set number. So that kind of gives you an indicator that elements are really designed around the number of protons they have. The periodic table is organized by that number of protons, and that number of protons is also called the atomic number. Now, parts of the periodic table, elements on the periodic table also fall into columns. Those columns give rise to the properties of those elements. We'll deal with that later. So, an element's name is going to be abbreviated using its chemical symbol. The chemical symbol for an element is going to be usually its first letter or first and second letter, but you'll notice that some of them, it isn't quite exactly that. Manganese is Mn because there already are some others that they can't repeat, obviously. Other things like sodium is Na. There's no N in sodium, but that is its original Latin name, natrium. So sometimes you'll notice that. The first letter is capitalized. The second one is lowercase. Now, for those of you that are like, uh-oh, I write in all caps. Well, then just make it a large cap and a small cap, okay? All right. The atom is the basic unit of matter. So there's 2 big categories of things in the universe. There's matter and there's energy. Matter, energy we'll talk about. We'll talk about that later. Matter is based on atoms. So atoms make up matter. Atoms are made up of a nucleus and an electron cloud. The nucleus is found at the center, so much like the nucleus of a cell. In the nucleus of a cell, that's where you find the DNA, so that's kind of the identity of that cell. The nucleus of an atom is where you find the protons as well as neutrons, but we'll get to that. And that's also the identity. So that's another way to remember, okay, so whatever's in the nucleus gives it its identity. So if you know protons are in the nucleus, that's how you know an element. The electron cloud, electrons are not in perfect rings. We see that image a lot, and in fact, I had one on the previous slide, but they are not in perfect rings. Now, we still use that model sometimes because it does help us represent certain things that we're trying to represent in quantum mechanics, but otherwise, they are found in a cloud. So they're fast-moving, spread out in this big cloud where they follow their own pathways, they don't interact with one another, and that's how it's set up. So this is a good picture of it. For lithium, lithium is element number 3, so it has 3 protons, 1, 2, 3. This one also has 3 neutrons, and then there's 3 electrons surrounding it. Notice they're not in rings, they're just kind of in a general zone. So the nucleus is where you are going to find your protons and neutrons. Now, protons are positively charged. We'll get to that in just a moment. Neutrons are neutral. And so when you have a bunch of pluses and a bunch of nothing, then the nucleus is going to end up being very positively charged. I would go ahead and pause and jot down this chart in your notes. So electrons are represented with the symbol E negative because they have a -1 charge. Their mass is almost non-existent. You could have 100 of them and they still wouldn't be anywhere near the mass of a proton. So electrons are extremely small, and when we get to nuclear chem, you'll understand why. They are found in the electron cloud outside the nucleus. Protons have a +1 charge, so electrons and protons kind of balance each other out. You typically will have the same number of each because if you have a bunch of positive charges, you're going to want a bunch of negative charges to kind of keep them in check. Protons have a mass of 1 AMU, so if we were measuring protons in grams, it would be like 1 × 10 to the -23rd grams. That doesn't work. So we use just the atomic mass unit. So the mass of an atom is based on the mass of its protons and neutrons because electrons don't really have a mass, and so therefore the electrons really don't affect the overall mass as a whole. Protons and neutrons are both found in the nucleus. Now, electrons, as we said, are found in the cloud around the atom, but some are closer to the nucleus, some are further out. The ones that are found all the way on the farthest reaches of the atom are going to be referred to as the valence electrons. Those are the ones that are on the outside surface of the atom, so they will be used when forming bonds. They could be gained or lost when forming ions, which we'll talk about in a minute. So that kind of, because they're on the outside, they're the easiest to gain and lose, and they're the easiest to use to interact with other atoms. So the nucleus is where you find all of the mass of the atom, because protons and neutrons are heavy, but electrons are not. However, the electrons being light, they're also moving around very quickly, and so they spread out and create a very large area for the atom. The atomic number of an atom is its number of protons. On our periodic table, that is located in the top corner. So for hydrogen, it's 1, the top left corner. Lithium, it's 3, beryllium, it's 4, etc. Then we have our average atomic mass. So carbon, for instance, can come in many different forms. You could have carbon 11, carbon 12, carbon 13, carbon 14. We'll talk about that a little bit more later, but the basic idea there is that carbon can come in many forms, and the mass of carbon in the universe is going to be an average of all of those different forms. So you're going to see that it is a weighted average of all the different forms that exist across the universe. And so it's the larger number. For hydrogen, it's 1.008, lithium 6.941, etc. So when you're calculating protons, neutrons, and electrons for an atom, we already said the atomic number is the number of protons. We also said that electrons are trying to balance out the protons, so they are going to be the same. Now, there are instances where they're not, and we'll talk about that in a moment, but they should be the same. Now, neutrons have the same mass as protons. So, protons and neutrons are all a mass of 1. So the mass of an atom, so if I rounded this to 197, if I have a gold atom that is 197 AMUs, every single one of those is based on a proton or a neutron. So if I know that the entire mass of the atom is 197, and I know 79 of those are protons, then I can subtract and figure out how many neutrons I have. So you take the atomic mass, round it, subtract the neutrons from it, or excuse me, subtract the protons from it. That gives you what's left over, which is the neutrons. All right. Now, atoms are sometimes represented using this symbol called the isotopic symbol. The atomic number is written down here at the bottom, so it's a little weird because based on our periodic table, it seems flipped, but realize that this was just editor's choice. There is no true thing that says the number has to be on the top or the bottom. The person that wrote this just decided that's where they wanted it. You can actually go online and find periodic tables where they're flipped already. So the atomic number of the atom goes on the bottom. So for beryllium, it's element number 4, so there's a 4. The mass number is the number of protons plus neutrons, so essentially the rounded atomic mass. But if you're told it's 9, then you know, okay, this particular beryllium has a mass of 9. 4 of those are protons, so 5 of those would be neutrons. If there's nothing here, you assume there's no charge on the atom, but if there is a number there, then that's the charge for the atom. In this case, there is a number, and it's a 2+. So this beryllium has an imbalance in its electrons. We'll get to in a second. But this is how we write that. So the isotopic symbol for these, you should write these so we can go over them on Friday. But a sodium atom... Okay, I got interrupted, but I'm here. All right, so the isotopic symbol that we could use for sodium with 11 protons and 12 neutrons. So what we would do, I'll see if you can see my board. I should be able to. We would say sodium is Na. That is the worst marker. We say sodium is Na, slightly better. The atomic number goes on the bottom, so we are told there's 11 protons, so there should be an 11 on the bottom. And then there's 12 neutrons. So the number that goes up here on the top is the combination of those two, so it would be 23. We are not told anything about the electrons, so that's all we got. For the next one, seeing one that has 11 protons and 11 neutrons. So in that case, I would still have 11 down here at the bottom, but the mass of this atom has changed slightly by 1. So this 23 would change to a 22. The last one, sodium with 11 protons, 11 neutrons, and 10 electrons. Ooh. So 11, 10 electrons, you'll see when we get to the next slide, indicates that we have a slight imbalance in charge. So the charge would go up there on the top right. All right, let's move forward. So charge of an atom is typically going to be neutral because if neutrons don't matter and protons and electrons are equal, they should cancel one another out. So the number of protons should equal the number of electrons. If they don't, so if you have the same amount, you would have 3 protons, 3 electrons. They essentially cancel one another out, so you're left with no charge. But that's not always the case. As we just saw, there could be unique types of atoms. Sometimes atoms have gained or lost neutrons, which changes their mass, and that makes it an isotope. We'll talk about that in section 2, because isotopes are their whole thing within themselves. But atoms that gain or lose electrons turn into ions, and the difference in their charges turns into the charge of the overall atom, and I'll show you how to do that. So ions are atoms with a charge. The charge comes from the imbalance between protons and electrons. So if I gain electrons, I end up with more negative. Let me go back because I have cations first, so let's do that. If I have an atom, and let's say I have 10 protons and I have 10 electrons, okay? And I lose an electron, so the electrons go down. The protons are now dominant. I have more protons than I have electrons, so the charge on an atom that loses electrons would be positive. Because if they're supposed to equal each other and one has gone down, I now have a situation where I have a positively charged ion. Positively charged ions are called cations. Now, I remember that one of 2 ways. Number 1, cats are amazing. Therefore, thinking of a cat ion makes me very positive. The other way is the T in cation looks like a plus sign, which means positive. So that works too. Anyways, so the other type of ion is called an anion, not an anion. Not an anion, an anion. I also remember people, I remind people that it's a negative ion. Anion, a negative ion. So anions are negatively charged because, again, a normal atom would start with the same number of protons and electrons, but in an anion, the electrons have gone up. And so the number of electrons is now higher than the number of protons, so the negative charge would dominate, and we end up with an overall negative charge. All right, so there's a lot of information in there. You may want to rewatch that video, but that's up to you. I do have here to take a minute to sum up your notes, but I don't think you really need to summarize it unless you want to. The way you're going to summarize it is with the atomic basics practice, okay? So the atomic basics practice sheet, I am going to be putting the key up on Friday, and we're going to go over the key and check to see how you did. It's okay if you have some issues and you want to clarify that stuff on Friday, okay? So if you have your answers on your paper and on Friday you come to our Google Meet and you're checking the key and you're like, no, then that's a perfect time to stay on the chat, talk to me about what you need. If you check the key and you're like, done, then you'll be done, okay? So make sure that you go ahead and do the atomic basics practice. I don't know why I'm struggling with that word or that sentence so much, and we will talk about it on Friday. See you then.